Welcome. I'll show you how to debug an exit with Trapper. I did this video because lately I saw a few problems being displayed in the various lists, and all were VSE based. And in VSE there's an excellent method to debug an exit. Example, I'm going to use the MAKEREL program, which is a setCF functionality for the assembler. setCF function in MAKEREL determines with that setCF function whether a branch can be converted to a relative branch instead of a branch with a base register and an offset. The problem we have with that is various programs have them, yeah. The problem is they have certain requirements which are not identical to a regular batch program. In CICS it's easy. They have all the same requirements, which is they must be proper CICS programs. But for the batch there are all kinds of ways exits have to be entered, and they are documented in IBM manuals and the various vendor manuals. And and how to debug them with Trapper pretty easy, and I hope you like it. Once you're finished reading the pages of the manual, maybe sometimes even multiple manuals, and just the setCF functionality, I'll show you. Okay. Once you've finished that, you may start writing your program, or you have a dummy program to look at the parameters. Whatever you decide to do, you come to a point where you would where you actually hit the iron, where you run it, and you would like to see what is in the registers, what is in the various areas provided. And to do that, we can use Trapper. First, you need to compile the program, and it needs to be stored. If you haven't done anything to the customization of Trapper, you need to store the resulting output list in class C under the user ID SYSA. I'll do that now. Compile. Okay, submit it to VSE, compiles it, and have checked the results. I know this compiles clean. So let's go to the next step, which is run the demonstration, or run the test program. Now here we have a test program, and it must run in class 4, and we would like to debug it, so we insert the necessary debug instructions. Set palm original program equals MAKEREL, comma, and we know that's, you must tell it where CICS in F2. Now that is usually all you need to do, but here we have a different program that must be called first before we go to that thing. So instead of changing that to Trapper1 and then passing control to MAKEREL, which will not work, we tell it to pass control to the first front end module equals RSM A90, and we change the exec to Trapper1. Now what happens is Trapper1 sets up everything, and then instead of calling the original program, which is what happens if you do it in batch, it calls ASMA 90. Now we submit that. Sub. And that is all. It's not all, of course. That's all you have to do as setup. Now we can go into CICS and start the transaction for batch debugging, which is trap, as opposed to with a P, that's CICS debugging, but here we have a batch program. And since F4 is already waiting for us, we can go into that thing and we can go into the source code itself by pressing PF11. Once that little plus sign is there, the PF11 is supported, and PF11 goes straight into source support, and it shows us that the first break did already occur, so the assembler has hit our exit, and we can now determine whatever goes on in whatever register we would like to see. And how about what I do is let it run a little bit till that instruction, and we do single stepping. I forgot. Let's see, PF1, and single step is PF9. Okay, single step, okay, now it loads register 4 from register 1. We can inspect register 1, R, and now we can look at that. And now we can look at the palms, go there and hit PF5 for show whatever is there. Yeah, that's it. Thank you for watching. Yeah, I now end the session because I know it works. 3 special commands and exit with removing the hook. Okay, that's it.